Hi, my name is Ross Anderson. I work on the operations research team in Google Research, and today I'm going to give a short video showing how to use OR tools, and specifically the MathOpt package within OR tool to solve linear programs and integer programs. Okay, so let's get started. So I'll do this first in an interactive shell, and then once I get it working, then I'll turn it into a short program and we can run it. So first you want to make sure you have OR tools correctly installed, and I'll just verify that I have installed it. I'll show you how to check that. So we'll open up IPython and just make sure that OR tools is installed. It's important and see that it doesn't crash. Import OR tools. Okay, it's here, and you can even check the version. And we see it's 9.9. 3, and as long as you're at least 9.9, then you'll have MathOpt installed on your machine. So let's get started. I want to save a little bit of typing here. So we'll make a shorter import statement from we can type a little bit less whenever we need to access MathOpt. Okay, so let's first document the problem we want to solve. So our goal is going to be to solve this integer program. Maximize 2 times x plus y, subject to x plus y is at most 1, and x and y are binary variables. Okay, so this is the problem that we want to solve. It's always good to write down a comment before you get started, because it'll be easier later to read the comment than to read the code. Okay, so we'll start by making a model. Creates a new model, and you can name it if you want. I'm not going to name it here. And now we need to add variables to the model. So we need 2 binary variables, x and y. Okay, and you can name them. Naming them is optional, but it helps. You need to debug things down the road. And make a y. Okay, so now to make the objective, call model.maximize. And you can use the arithmetic operators on the variables to create linear expressions, and this is what you pass into the maximize function. Okay, and now we'll add a constraint. Our constraint is that x plus y is at most 1, so either we pick x or we pick y, but not both. Add linear constraint. X plus y is at most 1, so this returns a value. We're going to ignore the return value because we don't need it for this problem. If you're doing LP and you need a dual solution, that's one reason why you use the return linear constraint. And so that's our whole model. So if you want, you can export the model to protocol buffer, which is Google's serialization format, and then print the text format of this. It's not the most human readable format. You can see there it is. You can see we have our 2 variables, our 1 constraint, and our objective coefficients. Don't worry about this format too much. And now let's solve the model. So to call the MathOpt solve function to do this. And the first argument is the model. Second argument is the solver type. This is an enum. And you can see we have a bunch of choices here. So because our model has all integer variables, and I want to use an open source solver, I will use cpsat, which is part of the OR tools project, and call solve. And so it's solved. It's pretty instant. If you want to see the kind of solver logs you usually see when you run a solver, you can turn that on with additional arguments to solve. So let's make sure that the solve succeeded. Always inspect the termination reason. Make sure that it is optimal or at least feasible before trying to get a solution out, otherwise an exception could be thrown. And so we see that the termination here was optimal, and that the objective value, primal and dual bounds match at 2, which is what we expect because our model was 2x plus y, and x is, so we expect x to be 1 and y to be 0 in an optimal solution. Okay, so why don't we see if we can get the values of x and y. So print result variable values x, and we see x is 1, and we see y is 0. Okay, so that's it. So now let's try and save our work into a file and clean it up so that way we have a reusable program, because this session will be gone when I close IPython. Just call save, and we'll put this into simple MIP.py. Okay, and there it goes. So we can open it up over here. And here's our program. Let's clean it up a bit. Need that. And need that. So what I'm going to do here is I'll change this print statement into an assertion. Assert, termination, reason. So now we'll get an error if the solver didn't find an optimal solution, because we expect the solver to be optimal here. In particular, like if the solver said the problem was unbounded, we want to try and access the variable values. It might not even be there. Okay, and I want to print everything on one line, so maybe I can make this output a little bit nicer. With a Python format string. Okay. I think that should work. So we'll save it, and let's try and run this program, and hopefully it doesn't crash. So Python, just a moment, see what happens. And we can see that it successfully printed out x is 1, y is 0. Okay, so that was it. That was a very simple demonstration of using the MathOpt library from within OR tools to solve a small integer program. And I hope you found it instructive. Thanks.